Alright, so these are the derivative rules. If you're taking the derivative of an ln of x, it's 1 over x. That is the derivative of x divided by x. So derivative over itself. So in general, that would be, regardless of what's here, it's derivative over original. Okay, so let's use that. Alright, so let's start with this part A here. Alright, so we're going to take the derivative of ln of 3x. So we're going to have derivative over itself. So that would give me what?
3 over 3x.
Alright, and then you can definitely do this. 1 over x. So notice this. What could you conclude from that little bit happening? If there's just a constant in front of x, it's going to go back to 1 over x. Right? So, alright. Alright, now this one, of course, a little different. So derivative would be
3x squared over x to the third plus 4.
Yeah. And I don't see anything we can do with that.
I don't get it.
Right? So we're done.
Cool.
Alright. Now. Oops. Alright.
Oh, Lord.
Okay,
First derivative,
cover up
second.
the unnecessary here. Alright, so what do you think?
Product.
Product. There's a product here, because you got this times this. So we're going to do like we do like with a chain rule or something. We're going to do product, but when we hit this, then we're going to use the ln rule. Alright, so we're going to have first times derivative of second, which is ln of x,
1 over x.
plus second, which is ln of x, times derivative of the first.
Don't we take away the ln of x?
We didn't do the derivative of it.
Okay.
We did, that was just second times derivative first. Alright, so there's not a whole lot we could do except just clean it up here. So here we've got 1, because that would wind up being x over x. 1 plus ln of x. Done. That's as far as we can go. Yeah, these derivatives aren't near as
Now-
bad as the algebra.
Now, quick.
Yeah.
Okay, I don't know if this just happened to work out, but
Uh-huh.
like, so you're multiplying the x and the ln of x,
Uh-huh.
and we learned that the log rules, if you're multiplying, you're adding. It's kind of like the derivative of the first one.
Well, yeah, I
You're
guess. Yeah, I had never thought about that.
Do
Yeah,
what?
I guess. Like when you do derivative, we're adding, and technically in the log rules, when you times, that's really add. But I had never thought about that.
adding. It might have just worked out.
It might have. Yeah, we'll watch that. All right. So now, what are we thinking here? Chain. Very good. So we got a chain rule, but within the chain rule, we're gonna do the ln. All right. So chain rule. 4 times ln. All right. Times the derivative of the inside. 1 over x. Derivative of the inside is ln of x, so that's that. So really,
4 over x.
4 ln of x cubed. Really, the 4's not cubed.
Oh, we can put it all over x.
That's about all we could do with that. The 4 wasn't cubed, just the ln of x. Alright.
It's a lot easier than the home.
I like it a lot better, I do.
Two.
Alright, so let's keep going.
Now we got to simplify it.
Alright, so let's do the radical one here. No big deal, because y'all know we need to use chain rule. Because this is the same as x plus 5 to the 1/2. So we're going to go chain rule again. You want?
Now, quick question.
Yes.
So, do we, because the parentheses is in around the ln, right? So this would just be the regular log function, or log derivative.
Oh, good question, good question. And yeah, I didn't recognize that until I looked at my paper. He's right, hold that thought. On this last one we did, all of the LM was to the fourth.
Yeah.
And we see the difference. And then this one like this. If it's like this, we need to rewrite this.